Okay, hello everyone. So today I will be discussing elastic collisions. Okay, so for an elastic collision, the important thing to take note of is that you have two objects, they collide, and after their collision, they go off on different velocities. Okay, and in that case, you could say that the mass is still the same, but the velocities will change. So the equation would then tend to look like this. M1 v initial or I 1 because the velocity of one object is different from the other. Okay, so you add that to m2 vi2. Okay, and after the collision, because momentum is conserved, it will look like m1 vf1 plus m2 vf2. Okay, excuse me, I accidentally tapped my tripod, but anyway, that is how it's expected to look like when we go through an elastic collision. So for today, let's tackle this problem. Let me read it for you and then we'll discuss how to solve it. Okay, so a 0.50 kilogram ball is traveling at 6.0 meters per second. It collides head-on with a 1 kilogram ball moving in the opposite direction at a speed of 12 meters per second. The 0.50 kilogram ball bounces backward at 14 meters per second after the collision. Find the speed of the second ball after the collision. Okay, so I think to tackle this problem, it would be nice to sketch what exactly happens before and then after our collision. Okay, so before the collision, you have a smaller ball and a larger ball approaching each other head-on. Okay, the smaller ball is said to have a mass of 0.50 kilograms as mentioned in the problem. The larger ball has a mass of 1 kilogram. Okay, but the initial velocities of both balls are different. Okay, for the smaller ball, it is 6 meters per second, and because we set the convention to be going to the right, that is positive. So VI1 is equal to 6 meters per second. Okay, and VI2 is 12 meters per second. However, it is moving in the opposite direction, which is important. Okay, so because it's moving in the opposite direction, we can then say that it is negative 12.0 meters per second. Okay, so that's before the collision. Now, after the collision, you don't know yet where each ball is going, but you know that they will have different velocities. Okay, but by standard, we could just set it to be one going this way, the other going that way. Okay, you know that the mass will be the same, 0.50 kilograms. The mass of object 2 will still be the same, 1.00 kilograms. Okay, but the velocity final of object 1 has changed now to negative 14 meters per second because it goes backward. So it becomes negative 14 meters per second. Okay, it's going to be interesting. So with that in mind, you now need to find VF2, which you don't know. Okay, so those are our unknowns. So let us now identify, or those are our known values rather. So our unknown value would be VF2. It's the only one we don't have. Okay, and for our equation, okay, let's just refer to the one that we used at the top. M1 VI1 plus M2 VI2 is equal to M1 VF1 plus M2 VF2. So that's our main equation. And I'm going to write that for a third time here in the solution. So M1 VI1 plus M2 VI2 is equal to M1 VF1 plus M2 VF2. Okay, now what we want to isolate in this case would be the unknown, which is VF2. Okay, so we have to isolate this. First step would be to transfer this particular function to the other side and then to transfer M2. Okay, so let's do that. So it becomes M1 VI1 plus M2 VI2. Okay, but this one being transferred becomes minus M1 VF1. is equal to m2 vf2. Okay, so that's one thing transferred, done. The next thing that we have to transfer would be m2, and we do that by dividing both sides by m2. Okay, so it will become m1 vi1 plus m2 vi2 minus m1 vf1 divided by the entire thing divided by m2. Okay, that one is equal to vf2. So now we have everything that we need in terms of what we have to plug into our calculator. There will be a lot of numbers involved, but bear with me because once you plug it in, I think it'll be straightforward as to what we're going to try to solve. Okay, so let's do it. So M1, what is M1? Okay, 0.50 kilograms. What is VI1? VI1, 6 meters per second. Okay, M2, what is M2? Okay, positive or plus M2, which is 1 kilogram. And then VI2, which is minus 12.0 meters per second. Okay. Okay, this will keep it tight in terms of space, but we got this. Minus, okay, M1 again, unchanged, 0.50 kilograms, times VF1, which is minus 14 meters per second. Okay, so that one divided by M2 is simply 1 kilogram. So all of that will be equal to VF2. So now that we have all of the things that we need to plug into our calculator, we might as well get our calculator out to solve. Okay, so let me just activate my calculator. Okay, there we go. So let's see, what do we have? So let's get the fraction out. So that's 0.5, okay, or let's use a parenthesis to make it more organized. 0.5, okay, multiplied by 6, okay, plus 1 times negative 12 minus 0.5 times negative 14, okay, and all of that is going to be divided by 1 kilogram. So press the equal sign in our calculator, okay, and that will leave us simply negative 2. Okay, so we now have an answer. Okay, that leaves us with VF2 is equal to minus 2. Okay, let's use 2 sig figs because that's our smallest. 2.0 meters per second. Okay, so if you think about it, does it make sense? So you have a big ball moving at a very high speed versus a small ball moving at a slow speed. And after the collision, the small ball moves at a higher speed but in the opposite direction, while the big ball moves in the same direction but considerably smaller. Okay, because the momentum is still equal, momentum is conserved. I think it makes sense that the big ball will see its speed reduced but not completely neutralized. So with that, our final answer is simply VF2 is equal to minus 2.0 meters per second. Okay, so that's how we solve an elastic collision problem. So again, elastic collision involves two objects colliding with each other and having different velocities before and after the collision. Okay, so for our next video, we will tackle inelastic collision, which basically means two objects that collide and stick together after our collision. Okay, so with that, take care and good luck. Goodbye.